In any situation where longitude by chronometer method can be used, the intercept method also can be used in place of long by chron. So at any time before the meridian passage of the body or after the meridian passage of the body, we can use this intercept method and find out the position line. Now let's see the procedure to solve a intercept question. We will see the information provided and how do we proceed ahead, what is the formula, and how do we obtain the PL and its direction. Now the information provided in these questions is exactly similar to what was provided in longitude by chronometer. So the information is they will give you the date and time. The time could be GMT, which is given in most of the question nowadays, or could be chronometer. In case of chronometer, there could be a chronometer ambiguity, which is resolved using the AM/PM indication given in the question. The second set of information is the sextant altitude, and along with it, they provide us with the index error of the instrument of the sextant and the height of eye of the observer, which is required for dip correction. And the third set of information was the DR position, the DR latitude as well as the DR longitude. So if you see, the information provided to us is exactly similar to what was in longitude by chronometer. So let's see the method also. The method is also quite similar. First of all, we enter into the almanac to get the information regarding the celestial body. We find out the hourly GHA from the daily page, the date page. Hourly GHA is obtained. We get the increment from the increment table, increment for the given minutes and seconds of the time. Then we pick up the V correction. V correction is required for planets and moon. So the hourly value of V correction is picked up from the daily page and its increment is taken from the increment table. Once all these three are combined, we obtain the accurate GHA of the body for that particular instant of time. Now once the GHA is obtained, we also have the DR longitude known to us. We apply the DR longitude and we get the LHA of the body. From the LHA, we can easily obtain angle P of the body. P will be equal to LHA if LHA is less than 180, and P will be equal to 360 minus LHA if it is greater than 180. The second item which is given in the almanac is the declination of the body. So we get the hourly declination from the daily page. We apply the D correction. D correction is given, hourly figure is given on the daily page. We get the increment from the increment table. And after applying it, we get the correct declination of the body. So this is the first step in which we get the GHA of the body, the LHA, angle P, as well as the declination of the body. Now in the second step, we have the sextant altitude. We apply the index error. If it is on, we put it off. If it is off, we put it on. Then we apply the height of eye with the dip correction. Go ahead, beta.
सर ये जो LHA आएगा, अभी LHA अप्रॉक्स नहीं आएगा क्या?
बेटा इसमें हम और कोई LHA नहीं निकालेंगे, so no need to write approx here.
तो सर उस वाले में DR लॉन्ग के साथ जब निकाल रहे थे तो LHA अप्रॉक्स आ रहा था.
That's right, because we were finding the accurate LHA also. If you want to write approx here, no issues, you can write.
Okay sir, यही LHA यूज करेंगे हम, जहाँ यूज करेंगे.
That's right, beta. No other LHA will be found in this question. Long by chron में we were finding two LHAs. One was the approx LHA using DR long. Second one was the LHA which we were finding with the value of P obtained from the formula. So just to distinguish, we had given it a name. So here we do not have any other LHA. So this is the only LHA which we have and which we'll be using.
Okay sir, okay.
Okay. So dip correction is always negative, and once we apply these two corrections, we get the apparent altitude of the body, and to this apparent altitude we apply the total correction and we get the true altitude of the body. Up to here the method is exactly same as long by Cron. Now comes the difference. From this true altitude we obtain the true zenith distance of the body. We know the true zenith distance is equal to 90 minus true altitude. So we get the true zenith distance of the body. Once these items are obtained, we are now ready to go into the intercept formula. So let's see the intercept formula now. The intercept formula says cos of CZD, that is calculated zenith distance, is equal to cos of P multiplied by cos of latitude multiplied by cos of declination plus minus sine of latitude into sine of declination. Let me explain to you these terms one by one. The first term here is calculated zenith distance. Till now we have seen three types or three different zenith distances. One was the true zenith distance, second was the MZD, meridional zenith distance, and this is the third one now, CZD, that is the calculated zenith distance. Now what is the difference between all these three? The true zenith distance is what is obtained from the true altitude, which is obtained from a site, from an observation. So if you get the true altitude and you use it to get the true zenith distance from a observation, from a site or observation which you have taken yourself, that is known as true zenith distance. Why it is called as true zenith distance? Because there is no scope of any error or inaccuracy in that zenith distance. The second one is MZD, meridional zenith distance. If we get this true zenith distance at the time of meridian passage, Marpass, just to differentiate it from a normal zenith distance, it is named as MZD. So MZD is nothing but the true zenith distance at the time of Marpass or at the time of meridian passage of the body. Now coming on to the calculated zenith distance. Now TZD and MZD were both obtained with observations. We used the sextant, and from the sextant we obtained the true altitude of the body, and that was used to get the TZD or MZD. Now there is a way with which the zenith distance of the body can be found out without an observation. That is by using the formula. Now this intercept formula which you see is basically the formula to calculate the zenith distance of any particular body. Just to give you an example, if I tell you to calculate the zenith distance of the sun for tomorrow, if I want you to calculate the zenith distance of the sun for tomorrow, what will be the zenith distance at this particular time tomorrow? So you obviously cannot find it out with observation. It has not yet happened. With observation, you can only find it in real time. But if you want to calculate it for the future, it can be done using this particular formula, the intercept formula. So when we use the formula to calculate the zenith distance of a body, it is known as CZD. The C standing for calculated tells us that this zenith distance has been obtained using the formula and it is not from a site or observation. So cos of CZD, that is the calculated zenith distance, is equal to cos of P. P is the angle P of the PZX triangle, into cos of latitude. The latitude used here is the dr latitude, that is what we have, into cos of declination. The declination of the body has been obtained from the almanac, plus minus. Again, you see two signs here in the formula. The same fundamental is used what we used in long bicron. That is, upper sign is used when the following terms are of the same names. There are two following terms. One is latitude, another is declination. So if lat and dec are of the same name, we will be using the upper sign, which in this case is plus. And the lower sign is used when latitude and declination are of the opposite names or different names. So be careful, in the long bicron formula the minus sign was on top, and in the intercept formula the plus sign is on top. So latitude again is known to us, the dr position is available in the question. The declination has been obtained from the almanac. So you see the right hand side, all the terms are available to us. P is known, we calculated P from LHA. Latitude is known, declination is known, lat and dec. So once you put all these values in the calculator with a single step calculation, you will be able to find out what is the calculated zenith distance of the body. So this is the intercept formula, a very important one. It should be memorized, and you should make sure that you do not make any mistakes in the formula. Now once CZD is found, what we do is we get the difference between TZD, that is the true zenith distance, and CZD, the calculated zenith distance. We find out what is the difference between these two, and this difference is what we call as the intercept. So intercept is nothing but the difference between the true zenith distance and the calculated zenith distance. Now once the intercept is obtained, we have to name the intercept. It is named in two ways. Either it can be towards the body or it can be away from the body. So towards the body or away from the body. Now what decides whether it will be towards or away? Now for that we use a shortcut method, a naming method, which is known as TTT. TTT, this is just a simple way or technique to memorize how the intercept is named. In the later slides, I will tell you what is the concept behind it. But as far as the solving of the practical question is concerned, you should be using this TTT, which is very quick and easy. And it tells us what will be the name of the intercept. What does the TTT means? First T stands for true. That means the true zenith distance. Second T stands for tiny. Tiny means smaller. And the third T stands for towards. So true, tiny, towards. That means if the true zenith distance is tiny, tiny means smaller than the calculated zenith distance, the intercept will be towards, and vice versa. So if the true zenith distance is tiny, intercept will be towards. If the true zenith distance is not tiny, the intercept will be away. So this is how we name the intercept. Naming is required to plot the position line. Later on, when I show you the diagram, it will become clear to you how is the naming used in plotting the PL. So once we obtain the intercept, the next step in the calculation is to obtain the direction of the position line. And as we know that in celestial navigation, the direction of the PL is always perpendicular to the azimuth of the body. So we find the azimuth of the body now in the next step. Azimuth is found using the same ABC method. A is equal to tangent latitude upon tangent P, named opposite to latitude if P is less than 90, and named same as latitude if P is greater than 90. Then B is equal to tangent declination upon sine of P, named same as declination. And once these are obtained, combining them together, A plus minus B or B plus minus A will give you the value of C, which is used in this formula. Tan azimuth is equal to 1 by C into cos latitude, giving you the azimuth of the body. Once the azimuth is obtained, the position line is perpendicular to the azimuth of the body. So these are the two items which we require. One is the direction of the PL. This is what we require. And second is the intercept. So once we have these two known to us, we are able to plot this position line on the chart or on our answer sheet in a plotting question. And the question is solved. Now this formula also, the cos CZD is equal to cos P cos lat cos dec plus minus sine of latitude sine of declination, is basically, if you look at it carefully, it is basically the same formula which we used in long bicron. Only some of the terms has been shifted from right hand side to left hand side and vice versa. Otherwise it is exactly the same formula, and it has been derived from the cosine formula only. So this was the full procedure of the intercept method, and once these two items are known, we are all set to plot the position line. So beta, you have the complete method in front of you now, right from beginning to end. Have a good look. Let me know any doubts coming at any step.
Sir, can you show in drawings of it? PL and Casimir.
Okay, how the
Thank you,
PL is
sir.
to be plotted. Okay, I'll show that beta.
Yes, thank you.
Let's now see, once the direction and the intercept is obtained, how do we plot the PL? We use the DR position as our reference. So we have the DR latitude, which is plotted in the diagram now. We have the DR longitude, which is plotted as a vertical line. So this is our reference position, the DR position. Now at this position, we mark the azimuth of the body. Let's assume the body is somewhere here. The azimuth will be the direction in which the body is. So the red color line represents the azimuth of the body. Now we have the intercept. Let's assume we have intercept equal to 3 miles towards. So what that basically means is, from the DR position, we go towards the body. And how much distance we go? We move a distance equal to the intercept, that is 3 miles. So from the DR position, you go towards the body a distance which is equal to the intercept. So once you cover that much distance going towards the body, the point where you reach is the point from where the PL will be passing. This point is known as intercept terminal point, or ITP. Now this is the point from where the PL position line will be passing, and the direction of the PL as always will be perpendicular to the azimuth of the body. So this is the ITP, the intercept terminal point, and we have the PL also plotted on the diagram now. The green line with double arrows marked on both the ends is our position line. Now whenever we plot a position line on the chart or on our diagram on our plot, we always indicate it by making arrows on both the sides, representing that this line is not contained to what has been drawn. This can be extended to both the sides. It can be extended to both the sides, and the vessel's position may lie anywhere on this line segment extended. So this is the intercept plot. So clear, beta?
Sir, in exam, we need to show this diagram, sir.
Yes, beta, if you get an intercept question, you should make the diagram also.
सर
Go ahead, beta.
सर कुछ क्वेश्चन है सर, जैसे नवंबर 22 में क्वेश्चन है सर, उसमें ये नहीं दिया कि कैसे सोल्व करना है, बस पूछा है डायरेक्शन ऑफ पीएल. तो सर उसमें लॉन्ग बाय क्रोन से करें या सर इंटरसेप्ट से करें सर?
I will tell you, beta. Let me first cover the side solving methods. I'll tell you what is to be done if the method is not given in the question.
ओके सर, क्योंकि सर पी की वैल्यू डिफरेंट आ रही है दोनों में, मैंने दो से सोल्व किया सर, दोनों मेथड से.
No problem. I'll tell you what is to be done. So we have a specific sequence which needs to be followed. So let me cover up the Polaris part, and then once we are covered, then I'll tell you.
ओके सर.
Okay. Great. So shall we move ahead, beta? Okay, let's go. Now, one important concept which I would like to clarify is the comparison between the intercept method and the long by Cron method. Now, I told you that wherever we use the longitude by chronometer method, it is possible to use the intercept method also. Now, it should be clear in your mind that whichever method you use, whether you use long by Cron or you use intercept, in both the cases, the position line what you are going to obtain will be the same. There will be no difference between the position line. It will be the same. Because of a concept, the concept is that from a single celestial body at a particular time, irrespective of whichever method we use, we can obtain only one single position line. So from a single celestial body at any particular time, we can obtain only a single PL. If we want two position lines, two different position lines, either we have to use two different bodies, or if we are not having any other body, let us say during daytime, we don't have any other body. At the time of twilight, we have a lot of stars which are available to us. So you can pick up two different bodies to get two PLs. Why we are interested in two PLs? Because two PLs are required to fix the vessel's position. A single PL is not going to fix the vessel's position. So in twilight, a lot of stars are available. We have access to many celestial bodies. But during daytime, it is possible only the sun may be there. Now, in that case, if we have only one single celestial body and you want to obtain two PLs, the only option is to stagger the observation. You take one observation at a particular time, wait for some time for the body to move, and then after some time you take another observation, that is known as a staggered observation, and you will get two different PLs. But at a single time from a single body, we can obtain only a single PL, irrespective of the method which we use. Now, how is that possible? We had different formula for intercept and for long bike run. How both of them can give us the same PL? Let's try to understand using this diagram. Now, this horizontal line which you see is the dr latitude, labeled here as dr lat. This vertical line which I am highlighting right now with the laser pointer is the dr longitude, and the delta position which you see here is the dr position. Now there is one more longitude which is given here, highlighted by the laser pointer now. This is the observed longitude. Let's assume we solved a particular question, and this is the observed longitude what we obtained. Now, using the long bike run method, we know that the PL is going to pass from dr lat and observe long, that is point Bravo. So we draw the azimuth of the body. This is the azimuth of the body, and perpendicular to the azimuth, the solid black line with arrows on both the sides, you have the position line. So this was using the long bike run method. Now, if the duty officer had used the intercept method in this particular case, what would have happened is, now for intercept method, the reference position is the dr position. So we will have to start from position D, delta. Now from this delta position, you will have to first plot the intercept. In this case, the intercept is away. So you have the azimuth of the body plotted here. The intercept is away. So you go from the dr position away from the body. The body is in this side. So you go away from the body a distance equal to the intercept, and the ITP which you are going to get will be this point Papa. And this ITP will lie exactly on the long bike run PL. So from this ITP, if you draw a line perpendicular to the azimuth of the body, you will get the PL again. And you will observe that from both these methods, whether it is long bike run or the intercept method, the position line obtained will always be same. We cannot have two position lines from a single body at a single time by using two different methods, intercept and long bike run. That's not possible. So this is the concept or comparison of longitude by chronometer and the intercept method.
Sir, but the azimuth which we get by long bike run will be different from intercept, na sir?
No, beta, the azimuth will come same.
No, सर वो जो लॉन्ग बाइक में जो इंटरसेप्ट निकालते हैं तो जो पी की वैल्यू होती है वो पी आफ्टर वो ऑब्जर्व लॉन्ग से आती है अपनी.
No issues, beta. The observed long and the dr long are not going to be that much different that their trigonometric ratios differ. So when you take sine theta, cos theta or tan theta, wherever you are using it, you will get the same answers.
Okay, sir. ठीक है.
So that position P will be a fix, right?
No, beta. We are only obtaining one single position line, whichever method we are using here, long bike run or intercept. For a fix, we need two PLs. So for finding the fix, we need to have another PL, and wherever they intersect, that would be the fix.
Okay. If there was one more body and another long bike run, then that P would have been a fix. Okay.
Right, beta. That's right.
Sir, what were you saying about the staggered? If there were position line with two timings, right?
I was saying, beta, if two bodies are available, then you can take the two sides and plot them and you will get a fix immediately. But if two bodies are not available, then only one body is available, let us say during daytime, you take one side, then wait for some time 1 hour, 2 hour, 3 hours, so that the body moves in the sky. Then you take another PL, and those PLs will be different and they can be combined to get a position. That's called a staggered observation.
Okay, perfect. Understand. Thank you.
Okay, beta. Great. So shall we move ahead now?
Yes, sir.
Very good. Let's go. Let's move on to our next method now, which is X meridian. Now, first of all, the meaning of this method, X basically means close. So X meridian basically means that the body is close to the meridian. It could be east of the meridian or west of the meridian, but it is close to the meridian. Now, practically, this X meridian method is not used nowadays. It has almost lost its practical relevance because we have other methods which are available which can be utilized in place of X meridian, like Intercept. Intercept can be used in these situations where X meridian is used, and it does not have any restrictions also. X meridian method has some restrictions. It can be only used for a particular amount of time or for a period of time. So we have the better method available to us now, and nowadays we use that. But theoretically, yes, sometimes questions based on X meridian, they drop in the papers. So we should be familiar with the working out of the X meridian site. Let's now go into the method. I will also explain to you the relevance, practical relevance of X meridian, how it is practically actually taken on board, and its comparison to Intercept. So for that, let's first understand the procedure of how X meridian method is solved. Let's see the information which is provided to us in the question. They will provide us the date and time. The time could be GMT or chronometer. In case of chronometer, there could be a 12-hour ambiguity, which will be resolved using the AM/PM indication given in the question. The second set of information is they will tell us that the body is close to the meridian or the body is near the meridian. Along with it, we will have the sextant altitude of the body, and as usual, the index error, the error of the instrument, the sextant, and the height of eye provided to us for dip correction. And we will also have the DR position given in these questions. This is the information which is provided, almost similar to what was there in long by Cron or Intercept, with only one addition, that a indication is given that the body is close to the meridian or near the meridian. Now, as far as our exam questions are concerned, wherever this indication is given, body is close to the meridian or near the meridian, the paper setter wants you to attempt this question using the X meridian method. So this is the intimation provided to us to denote that X meridian is to be used in these questions. So let's go into the procedure now. The first step is similar to what we have already done. We obtain the almanac information of the body. We get the hourly GHA, apply the increment, apply the V correction increment if required in case of planets and moon, and we get the accurate GHA of the body. We have the DR longitude available to us, and once applied to the accurate GHA, we get the LHA of the body, and this LHA gives us angle P. Now we obtain the hourly declination from the day page. we get the value of hourly decorrection, we check its increment from the increment table, apply it, and that gives us the correct declination, the accurate declination of the body. So this is the first step. Now in the second step, we correct the altitude of the body. The sextant altitude, we apply the index error. If it is on, it is put off, that means negative. If it is off, it is put on, that means positive. Then we apply the dip correction from the height of I, which is provided to us in the questions. And once these two are applied, we get the apparent altitude of the body. Now to this apparent altitude, we apply the total correction, and this gives us the true altitude of the body. Once true altitude is obtained, we can get the true zenith distance of the body, which is 90 minus true altitude. So once you have calculated up to here, you are ready to go into the intercept formula. Let's see the intercept formula. Intercept formula is cos of mzt is equal to cos of tzd plus 1 minus cos p into cos of latitude into cos of declination. Now let us understand the terms one by one. The first term which you see is the meridional zenith distance, that is the mzd. Now before I explain the remaining part, let me explain to you a little bit the relevance of X meridian. I told you that nowadays it is practically redundant, but in the olden days the X meridian method was in use. It was helpful to us, and the reason for that was that at the time of meridian passage, if there is any reason, cause or interruption because of which a Marpas site cannot be obtained. It could be that it was raining at the time of meridian passage, or the sun or the celestial body was covered with clouds. You could not take a sight at that particular instant. Now Marpas is an instant. So if you miss that instant, then the meridian passage sight is not possible. It happens only once in a day for the sun at the noon time. So if you miss that instant, the Marpas site cannot be obtained. Now it was very important in the olden days to get a Marpas site, because our passage calculation, which is also known as day's work, the passage calculation or day's work was based on the noon position, the Marpas position, and we used to calculate the distance traveled, distance made good, engine speed, all these things, the distance remaining, what is the fuel. A noon report was prepared every noon, giving a full summary of the passage for the last one day, and it was sent to all the concerned parties, the owners, the managers, the charterers, all these parties. So if you missed the Marpas site, the day's work calculation will get affected. Nowadays we are not bothered because we are getting a real-time position from GPS, and the day's work can be easily calculated from 1200 to 1200, whether you take a sight or not, whether there are clouds or not, whether there is rain or not. But at the olden times, when GPS satellite positions fixing was not there, this was the only method with which the day's work could be calculated. So in case a Marpas site was missed, the only other option available to us to get the MZD, see, the Marpas site gave us the MZD, meridional zenith distance. Then this MZD was combined with declination to get the observed latitude. So we wanted a way to get the meridional zenith distance in case the Marpas site was missed, and this is why the X meridian method was used. So we can calculate the MZD, though it is not a Marpas site, it is taken before or after meridian passage. It is not a Marpas site, but still using this we can calculate the MZD, and this MZD can be combined with declination in the same way as was done in a Marpas observation to get the observed latitude. So that was the whole purpose of X meridian. So cos of mzd is equal to cos of tzd, that is the true zenith distance. It has been calculated already from the true altitude of the body, plus 1 minus cos of p. P is available to us. We had calculated the LHA, which gave us the value of P, into cos of latitude into cos of declination. The latitude used is the dr latitude. The declination is available from the almanac. So all the terms on the right hand side are available to us. We put them in the formula. Using the scientific calculator with a single step calculation, we can obtain the mzd. So this is again a very important formula, not to be forgotten. Make sure that you apply this formula correctly. Now once you get the mzd, you can combine the mzd and the declination exactly in the same way as we did in a Merpass observation, latitude by meridian altitude observation. And once you combine them, we obtain the observed latitude. So exactly in the same way as we had the observed latitude, we get the observed latitude. Now the combining was by giving a name to the mzd. We had done a shortcut method. You first give name to the true altitude. The name to true altitude is the same as the azimuth of the body, in whichever direction the body is, north of the observer or south of the observer, the same name is given to true altitude, and opposite to that is given to tzd as well as mzd. So once the mzd name is there, you have the declination name given in the almanac. Same names you combine. Opposite names you subtract the smaller one from the bigger one and retain the name of the bigger one. It gives you the observed latitude. Now up to here this was similar to the Merpass observation, but after this there is a difference. The difference is, number one, the observed latitude which we got in a Merpass observation was also the fixed latitude. The observer has to be somewhere on that latitude only. But in this case, the observed latitude is not the fixed latitude. Why not? Because in this case, the azimuth of the body is not exactly north or south. The azimuth is close to north or south, but not exactly north or south. Because the body is not on our meridian, the body is close to the meridian. If the body was on the meridian, azimuth will be north or south and the direction of the PL will be exactly east-west. Anywhere on that PL you will be on the same latitude. But in this case, the body being not on the meridian, azimuth will not be exactly north-south. Similarly, the PL also will not be running exactly east-west. It will have some different direction. And that is why, depending upon where you are on the PL, the latitude is going to change. I will show you with the diagram also in the next slide. But to remember, the observed latitude, what we get in the X meridian method, is not our fixed latitude. Then how do we use it to obtain the position line of the observer? So for position line, we have to calculate the azimuth of the body. The azimuth as usual will give us the direction of the position line and we will plot that PL on the chart. So for azimuth we use the ABC method. A is equal to tangent latitude upon tan P. B is equal to tangent declination upon sine of P. We combine both of them to obtain the value of C, and then we use it in the tan azimuth 1 by C into cos lat formula to get the azimuth of the body. Once the azimuth is obtained, we know that the position line is perpendicular to the azimuth of the body. So we have obtained the azimuth and we have obtained the observed latitude. These are the two data items which are required to plot the position line. Once these two are known, we can plot this PL on the chart or in our plot. So beta, you have the complete method now, right from beginning to end. So let me know any doubts coming in.
Sir, you said observed latitude is not a fixed latitude, no? So how will fix or fix the position to get the position to get this azimuth?
Beta, this latitude will tell us how to draw a PL. I'll show you how the PL is drawn, and we have to combine that PL with another position line to get our fix.
सर इसमें करेक्शन लगता है ना?
नहीं बेटा, जो करेक्शन लगता था, that correction was or reduction basically, that was when we were using X meridian tables. With this method, with calculator, there is no correction.
ओके सर.
So चलें बेटा, PL plot करें?
Yes, sir.
Very good. Let's go. Let's see the X meridian plot in the diagram. Now, the reference position where the X meridian PL is plotted or drawn or passes through is the DR longitude and the observed latitude. So this is the reference position, observed latitude, which we calculated from the Marpass formula, the X meridian formula, and the DR longitude. This is the position from where the PL is going to pass. Now, after plotting these two, we plot the azimuth of the body. The body is close to the meridian, so let's assume our celestial body is here. The direction in which the body is represents the azimuth of the body, and perpendicular to the azimuth is going to be our PL. So the green color line with arrows on both the sides represents the position line or the LOP. Now you can see that the observer or the vessel can be anywhere on this PL, and if it is at any point on this PL, it is possible that the fixed latitude may be different from the observed latitude. Observed latitude just gives you a reference position from where the PL is passing. It does not give you the fixed latitude in this case. So depending upon where you are on this PL, which we will find out when we have a second PL, wherever the second PL crosses it, that will be our fix. So depending upon at which point you are on this PL, the latitude is going to differ from the observed lat. So this is the X meridian plot. So I hope it is clear now, beta.
सर एक ऑब्जर्व सर हमने एक्स मेरिडियन से पीएल निकाला, ऑब्जर्व जो हमारा कैलकुलेट हुआ वो निकाला. फॉर एग्जांपल अगर ये मैंने 11 बजे लिया सुबह या 11:30 बजे लिया, अगर मैं 4 बजे दूसरा कुछ लेता हूँ, 4 बजे मैं फॉर एग्जांपल कुछ भी और लेता हूँ, उसके अंदर मेरा ऑब्जर्व लैट अलग आएगा, राइट? क्योंकि दिस लैट कैन नॉट बी द अदर लैट, राइट? बिकॉज ये लैट इतना एक्यूरेट नहीं है, ऊपर नीचे हो सकता है उसके प्लॉट में.
तो बेटा आपने जो 1600 पे जो साइट ली है उसके लिए अलग बॉडी को यूज किया ना, और उसको भी एक्स मेरिडियन से ही सॉल्व किया?
नहीं, उसको तो अलग से किया है, नहीं तो फिर सेम लैटिट्यूड आ जाएगा ना सर, सेम गलत लैटिट्यूड आ जाएगा.
No, if you solve it with some other method, then whatever method you use, we will plot the PL as per that method. Let us say you use long by Cron, we will plot the PL as per long by Cron, and we will transfer this PL to 1600 wherever they intersect will be the fix.
Okay.
हम सेम डायग्राम में सर दोनों को नहीं दिखाते कि हमने 12 बजे वाला ये भी दिखाया वो भी दिखाया, तो उस डायग्राम में ऑब्जर्व ऊपर नीचे आएगा ना?
You can show it in the same diagram if the positions are not too far away. Okay. If you are doing it on the chart, certainly both the PLs will be on the same chart.
सर ये लैड बाय मरपस में भी सेम ही बनाते थे ना, ऑब्जर्व लैट और डीआर लॉन्ग को लेके?
हाँ बेटा, ओनली डिफरेंस इज उसमें एजीमुथ नहीं होता था और उसमें जो पीएल है वो ऑब्जर्व लैट के साथ मैच कर जाती थी. दैट इज द ओनली डिफरेंस.
ओके, गॉट इट सर, गॉट इट.
ओके बेटा, अभी बताता हूँ. I'll tell you now. Let me explain that. Let me show you. Now, one important thing not required right now in these X meridian questions, but the concept should be clear in your mind. It will be used in star identification question. The concept is used in star suitable for sight questions, and may also be asked to you in orals. Now, I told you that this X meridian method is used when the body is close to the meridian. Now, the next doubt which comes to the mind is, how close is close? Somebody could feel if the azimuth of the body is 355, it is close. And somebody would say, no, it's gone far away. The Marpas azimuth should be 000 or 360, it's at 355, it is too much. So how close is close? Or in other words, what decides whether a body can be observed and the sight can be solved using the X meridian method at a particular time or not? Now, I also told you that this X meridian method has some restrictions as compared to the intercept method. Intercept method does not have any restrictions at all. It can be used at any time other than the Marpas. The X meridian method, on the other hand, has some restriction. It can be used only for a certain period of time. To give you an example, let us say if the meridian passage of the sun was at 1200. Now, for using X meridian, there is a particular band of time, a period of time in which it can be used. Just to give you an example, if that band or period is 15 minutes, so 15 minutes before Marpas and 15 minutes after Marpas, that is the period in which X meridian can be used. If the body has gone outside that period, the time has moved outside that period, the X meridian method cannot be used in that case. What should be used in that case? The choice is intercept method. So if the body has gone out of this limit, then we can use the intercept method. Now, how to find the X meridian limit? For finding the X meridian limit, we have the X meridian tables. They are there in the Norris tables. Let me show the tables to you. You can see the X meridian table 1 on the slide now. There are total 4 X meridian tables. Table 1, table 2, table 3 and table 4. In the olden days when we did not have the calculators, then all these 4 tables were used to work out a X meridian sight. But nowadays the calculations are done with scientific calculators. So we do not require table number 2 and 3. Their purpose is solved using a calculator, but we require table number 1 and table number 4 to obtain the X meridian limit. So let us see now, how do we obtain the X meridian limit for a particular body? Now, if you see in this X meridian table number 1, you can see on the horizontal axis we have the declination. This is the declination of the celestial body whose sight is being taken. and on the vertical axis you have the latitude. This is the latitude of the observer. So this table is entered using the latitude of the observer and the declination of the body. Now let's assume that the declination was 40 degrees. Latitude was 10 degrees. So 10 degrees latitude and 40 degrees declination. The table gives us a value of 2.96. This is also known as factor A. You can see it here. It is mentioned as factor A. So we have obtained the factor A from X meridian table 1. In this particular example, we have taken 40 degree declination and 10 degrees latitude, and it comes to be 2.96. After obtaining this factor A, we enter into table number 4. So up to here, okay, beta. Shall I move to table 4?
Sir, in table 1 it does not mention the direction of, is it north latitude or north declination? Is it irrespective of that?
Okay, beta. If you look at the table carefully on top, you will see this table which I am showing you. It says latitude and declination, same name. So when both are same names, you use this particular page. And when they are of opposite name, there is a separate page which is given in the table.
Okay, sir.
Okay. So let me.
We need to use this table.
Beta,
Solution.
not in a normal question, but if in any question they ask you to determine the X meridian limit, then you need to use this table. Later on, I'll show you one question which comes on star suitable for site. There we will be using it and we will be calculating the limit.
Sir, this limit is in time, minutes, correct? Like
No, not
2.8, that is
नहीं
2.8.
बेटा, अभी मिनट नहीं मिले हैं, अभी सिर्फ फैक्टर A मिला है. I'll show you from factor A how the minutes are obtained.
Okay. इसमें इंटरपोलेट करना पड़ेगा सर for now.
I'll tell you beta. We have got a factor A of 2.96 from here. Let's go to table 4 now. You see the table number 4 on the slide now. This is X meridian table 4. So in this table 4, we enter with the factor A, which we got from X meridian table 1. So you can see this table gives the limits for using the X meridian tables. The limit is in minutes of time before or after meridian passage. So you can see the factor A mentioned in this column, starting with 30, 25, 20, 15, so on, and going up to 0.7 in the last column. And with this factor, you have the maximum interval given in minutes of time. So let's try to find out the limit for our example. We had the factor A as 2.96. So you see it starts with 30, 15, 10, 7, go in the next column, 6, 5, 4, 3.5, 3, 2.8. Now the value which we have nearest to our value was 2.96. The nearest one which we have here is 3.0. So 3.0 gives us a limit of 32. This basically means 32 minutes before or after meridian passage. So it tells us that 32 minutes before Marpas and 32 minutes after Marpas is the time period in which the Marpas method, the X meridian method, can be used. So if our Marpas was at 1200 hours, 32 minutes before, that's 1128 and up to 1232. From 1128 to 1232, the meridian passage, the X meridian method can be used for obtaining a position line. If the time has gone outside this window, let us see, it is 12:33 now. So it has gone outside the X meridian limit. This is known as X meridian limit, in short also known as EML. If the body or time has gone outside the X meridian limit, then this method is not recommended. This method will give us substantial errors. It is not recommended and we should not be using this method then. In this case, we should be using, if the body has gone outside the X meridian limit, we should be using the intercept method instead. So this is how we determine what is the X meridian limit for a particular body and for a particular observer.
Okay, sir, one doubt.
Bolo beta.
So like what Sumit had said, like when no method is mentioned, and like what you said now, that after X meridian has passed, it has to be solved by intercept. So if
Right,
no
beta.
method is mentioned, we have to go for intercept.
Right, that's right.
Oh, okay, thank you.
सर ये 32 मिनट्स क्या था सर, रेंज था ना ये?
Yes, beta, this is the
Yes,
X meridian limit. Means 32 minutes before Marpas and 32 minutes after Marpas, the X meridian method can be used.
आप एग्जांपल क्या लिया था सर आपने टाइम का?
12 o'clock.
Yeah, if you take 12 o'clock as your meridian passage time, then 32 minutes before that and 32 minutes after that will be the window in which X meridian can be worked out.
Okay sir, got it.
सर एक छोटा सा डाउट है, आई एम श्योर कि आपको पहले बताया होगा. तो हम बेसिकली इंटरसेप्ट कभी भी यूज कर सकते हैं, लॉन्ग बैकग्राउंड कभी भी यूज कर सकते हैं, एक्स मेरिडियन हमारे पास टाइम रेस्ट्रेंट है, और सर हम लैटिट्यूड बाय मेरिडियन भी कभी भी यूज कर सकते हैं, राइट सर?
ओके, थोड़ी इसमें एडिटिंग है बेटा. लैटिट्यूड बाय मेरिडियन ऑल्टीट्यूड कैन बी यूज्ड ओनली व्हेन द बॉडी इज ऑन योर मेरिडियन, ओनली एट द टाइम ऑफ मरपास. इट विल हैपन वंस इन अ डे फॉर ए नॉर्मल बॉडी.
नून टाइम के आसपास उसका भी ओके सर, उसको तो हम थोड़ा लेट भी, मतलब उसकी भी कोई लिमिट हो सकती है सर कि हम एग्जैक्टली हमारे ऊपर होगा तब तो हम कर नहीं पाएंगे, तो वो थोड़ा आगे पीछे ही होगा ना उस टाइम पे सन?
नहीं बेटा, इट हैज टू बी एग्जैक्टली ऑन योर मेरिडियन. मींस बॉडी की बियरिंग एग्जैक्टली नॉर्थ या साउथ जब आएगी तभी आप मरपास साइड ले सकते हो.
ओके,
नॉट एट एनी अदर टाइम.
So that's why when we calculate the Marpas time, we have to come like 10 at least 10 minutes before and put the sextant and wait for the Marpas time to come the sun on the meridian, right?
Right beta, right, you are right, exactly right.
कौन करता भाई कैलकुलेट?
अरे भाई
सर ये टेबल में एक बार
मैंने तो
बताना
किया है
कैसे देखना है?
मैं लेट जाता हूँ भाई.
हाँ बेटा, बताओ और क्या डाउट है?
सर कैन यू प्लीज टेल सर अगेन हाउ टू सी दैट दिस टेबल सर?
बेटा टेबल 4 या टेबल 1?
टेबल 4 सर, आफ्टर फाइंडिंग वैल्यू फ्रॉम टेबल 1 देन कमिंग टू टेबल 4.
बड़ा सिंपल है बेटा. टेबल 4, जो वैल्यू आपको टेबल 1 से मिली थी उस वैल्यू को फैक्टर ए के नीचे आप आइडेंटिफाई करो एंड वेयर एवर यू गो इन फ्रंट ऑफ दैट वैल्यू यू विल गेट द लिमिट. जैसे हमारी वैल्यू आई थी 2.96, द क्लोजेस्ट फिगर टू इट इज 3.0 एंड 3.0 गिव्स अस ए लिमिट ऑफ 32 मिनट्स.
Okay sir.
Sir, it means we can use long by clone and intercept method at any time, right? Except lat by.
Okay, I'll tell you better. I'll tell you. Listen carefully. First, coming to Marpas method. Marpas method is only used when the body is on our meridian, which happens once in 24 hours for a normal body. Coming to second method, longitude by chronometer, can be used anytime with one restriction. Long by chron is not recommended when the body is close to the meridian. Long by chron is not recommended when the body is close to the meridian. Other than that, it can be used anytime. Coming to third method, intercept. Intercept has no restriction. You can use it any time of your choice. Method number 4, X meridian method. X meridian method can be used only within the X meridian limit. And method number 5, Polaris. Polaris also can be used at any time provided Polaris is visible to you. This is the summary.
Sir, it means we can also use intercept method, right? When the body is exactly on our meridian.
Certainly, beta. On your meridian, using intercept will be of no use because when the body is on the meridian, only method which you use is marpass.
Okay, sir. That is the reason they came out with Marpas because we can't use intercept at that.
Aha. Okay, that's right. सो बेटा मैंने ये टेबल जो है ये वही टेबल है जो हमने मेरिडियनल पार्ट्स के लिए यूज किया था. मैंने वो सिलेक्टेड पेजेस आपको फिर से भेज दिए हैं ग्रुप पे. सो यू हैव दिस एक्स मेरिडियन टेबल देयर इन दोज पेजेस, राइट?
Sir, just one small doubt. Like this example, what you have taken, where latitude and declination are same. So when latitude and declination are different, ज़्यादा difference नहीं है ना sir?
नहीं बेटा, आप देखोगे टेबल 1 में देयर आर सेपरेट पेजेस फॉर सेम नेम एंड ऑपोजिट नेम. इफ यू वांट यू कैन जस्ट स्क्रॉल नाउ इटसेल्फ. So whichever applies to you in a particular question, you will go to that part of the table.
Polaris का क्या मतलब sir? When the Polaris is visible to us, no?
Yes, that's right, beta. That's right.
सर
बोलो बेटा.
सर हम जब ऑन बोर्ड साइट बनाते हैं तो मॉर्निंग साइट जो बनाते हैं वो मोस्टली सर लॉन्ग बाय क्रोन की बनाते हैं सर. सर कुछ एक्यूरेसी में सर कुछ एक्यूरेसी पॉइंट ऑफ व्यू से कुछ डिफरेंस है लॉन्ग बाय क्रोन और इंटरसेप्ट में सर?
नहीं बेटा, when we are using calculator, there is not much of a difference in accuracy for long by cron as well as intercept. Both are equally accurate.
भाई साइड बुक चल रही है क्या अभी जहाज पे?
चल रही है यार, चलानी पड़ रही है हमको तो.
नो मोर. हाँ भाई तो ज्ञान करवाते हैं.
ऑडिटर पूछता है, ऑडिटर आ गई.
शायर वाले पूछते हैं यार, शायर वाले चेक करते हैं यार.
अरे यार प्रैक्टिकल सुब्रमण्यम की किताब की प्रैक्टिकल लैब का वो एक सॉल्यूशन डाल के और पोजीशन अपने जहाज के लिख के हो गया.
सर एक चीज, सर एक डाउट है.
बोलो बेटा.
सर इस जो आपने ये जो एक्स मेरिडियन टेबल 1 और
बेटा योर माइक इज म्यूटेड, प्लीज अनम्यूट एंड स्पीक अगेन.
सर मैं कह रहा हूँ कि जो हमें एक्स मेरिडियन की टेबल्स होती हैं नोरिस टेबल में, उसमें कुछ एरियाज होते हैं जहां पर फैक्टर की वैल्यू नहीं दी हुई है.
राइट, यू हैव अ ब्लैंक.
Yeah, it's a blank like a yes sir.
Right, beta. That blank strike basically tells you that if you fall in that region, then X meridian will not be possible.
Okay.
You will have to use intercept in that case.
Understood, sir. Okay. So eventually वो let out आने वाली थी कभी ना कभी.
Right, beta, right. So if you don't get value of factor A, you have to use intercept.
So what is the maximum? So you are going to answer this question. You said at the end of the explanation. What is the maximum limit, sir, for X meridian? EML?
Okay. Just have a look at the table and tell me which is the maximum value.
71 minutes.
Exactly, beta. That is the time maximum limit, 71 minutes for X meridian. Now it is possible that you may have a later addition of Norris table. I think in that the limit is extended up to 76 minutes. So 76 minutes is the maximum time where X meridian can be used, no more than that.
So then that is total 152 minutes before and after meridian passage, right?
No beta, this 71 minutes is before and after. So if you make the total window, yes, it will be 142 minutes.
Okay, sir, correct. So
this is plus and minus 71 minutes from our pass.
Okay. So that means it keeps on changing then.
It will, beta, as the declination changes, as the latitude changes, the limit is also going to change.
Okay, thank you.
So even if you don't understand this, it is perfectly fine. I will be taking up rational horizon later on in detail. So if any doubts are there, they will be sorted out that time. But let us first just go through the concept behind the Polaris observation. Let's now try to understand the Polaris or pole star observation method of obtaining a position line. This is also a very quick and easy method with which the position line can be obtained. It does not involve any formulas, not much calculation, and we can obtain a PL very fast using this method. Now, before we go into the stepwise procedure, we need to understand the basic concept, the underlying concept on which this method is based. Now, for this, we need to make a rational horizon diagram. Let's assume our observer is in north hemisphere, and let's make a rational horizon diagram for him. You can see the rational horizon diagram made on the right side of the screen. At the center of this diagram, we have the zenith of the observer, the point directly overhead represented by alphabet Z, and on the circumference we have the points N, E, S, W representing the rational horizon of the observer. Our observer is in north hemisphere in this case. Now, when the observer is in north hemisphere, the equator will be south of the observer. Similarly, on the celestial sphere, the equinoctial is going to be south of the zenith of the observer. Equator is projected onto the celestial sphere as equinoctial. Observer's position is projected to the celestial sphere as the zenith. So let's show the equinoctial in our diagram. The equinoctial in the rational horizon diagram always passes from east and west points. So let's draw the equinoctial. You have the equinoctial in the diagram now passing from east and west point, and it is passing south of the zenith. Our observer is in north hemisphere, that's why the equinoctial is passing south of the zenith. The point where the equinoctial crosses the observer's meridian is represented by Q. So you can see the Q point marked in the rational horizon diagram now. Now, since Q represents the equator on the celestial sphere, Z represents the position of the observer on the celestial sphere, this arc of the meridian between Z and Q, the arc ZQ, represents the latitude of the observer. So ZQ being the latitude of the observer. Now let us show the pole in this diagram. The pole is 90 degrees away from the equinoctial. So from point Q, I go 90 degrees away, and somewhere here we will have the north pole visible to the observer. The observer is in north hemisphere, so the pole which will be visible to him will be the north celestial pole. The south celestial pole is going to be below his horizon. South celestial pole will be 90 degrees south of the equinoctial or the Q point, and it will be below the horizon of the observer. So we have the pole shown in the diagram now. Let's mark the pole with point P. Now with the pole visible in our diagram, let's now concentrate our attention to arc NP. N represents the north point of the observer's horizon. N point is on the rational horizon, and P point represents the celestial pole, north celestial pole. This arc N to P is basically the altitude of the pole, or it is also known as the elevation of the pole. You see, N point is on the horizon, P is the celestial pole, So N to P marks the arc of the vertical circle contained between the pole and the horizon. This is the definition of altitude. So NP is the altitude of the pole, also called as the elevation of the pole. Now, we are aware that this celestial pole is 90 degrees away from the Q point on the equinoctial. We are also aware that the N point, which is on the horizon, is 90 degrees away from the zenith of the observer. So now you see point P is 90 degrees away from the equinoctial, that is Q. Point N is 90 degrees away from the zenith. So the difference between Z and Q will be the same as the difference between N and P. Or in other words, the arc ZQ will be equal to the arc NP. So with this, we come to know that this NP will be equal to the latitude of the observer. In other words, you can say that the altitude of the pole or the elevation of the pole straight away gives us the latitude of the observer. So we get a very easy method to obtain the latitude here. If we can take the altitude of the pole, it will immediately give us the latitude, which is a very simple and easy way. The only problem here is the celestial poles are not lit up. If they were lit up, there was some star or some light there, then we would be able to take their altitude and get our latitude very easily. But unfortunately, the poles are not lit up. But there is one star, special star, which is very close to the north celestial pole. There is no such star close to the south celestial pole, but we have one star which is very close to the north celestial pole, and that star is the Polaris. Other name for it is the pole star. Since it is very close to the north celestial pole, it is called as the pole star. Now this star is having a declination of 89 degrees and 10 minutes. So it is within 1 degree of the celestial pole. So with this star being so close to the pole, if we take the altitude of this particular star, then it can very nearly give us our latitude. So this is the concept behind the Polaris or pole star observation. Pole star being a special star very close to the north celestial pole, if we take the altitude of this pole star or Polaris, it gives us very nearly the latitude of the observer. If the pole star was exactly at the same place where the north celestial pole is, in that case it would give us the latitude exactly, accurately, without any difference or error. But since it is not exactly where the pole is, it is slightly away from the pole, the altitude what we get from the observation of Polaris is also not exactly same as our latitude. There is a small difference between the two. Now this difference which is there between the altitude of the pole star and the latitude of the observer is tabulated in a table in the nautical almanac. We can obtain that difference from there. We can apply that difference to the altitude of the pole star, and once applied, it gives us our latitude. So this is the basic concept behind the Polaris observations. We have the Polaris table or the pole star table given in the nautical almanac, which provides us this correction, which can be applied to the altitude of the pole star to easily obtain the latitude of the observer. So beta, I hope you have understood something. Even if it is not fully clear, it's perfectly fine.
So I have some doubts. How the latitude said Q is equal to NP.
Okay beta, understand it this way. ZQ is the latitude and P to Q is 90 degrees. So can you tell me what will be PZ?
90 minus ZQ.
Very good. 90 minus latitude. So PZ is 90 minus latitude. Now Z to N is again 90 degrees. PZ is 90 minus latitude. So what will be NP?
90 minus PZ.
90 minus 4 latitude.
90 minus
NP
sorry, sir, I'm not getting it.
So did you get the answer, beta?
So NP will be 90 minus PQ, right, sir?
Sir, NP plus PZ is equal to PZ plus ZQ. PZ कट जाएगा.
Beta, ZQ is latitude. P to Z is 90 minus latitude. Z to N is 90. So 90 minus latitude, NP. It gives you latitude again. Did you get it? Or shall I?
Okay. Okay, sir. Okay.
Okay. Okay, beta. So let's move on to the Polaris question now. We will see the table, Polaris table, and see how the correction for Polaris is made. Let's go. Now this correction which we apply to the altitude of the pole star or altitude of Polaris to obtain our observed latitude is available in the almanac. We have a Polaris pole star table. You can see the Polaris pole star table in the 1992 almanac on the screen now. It's given on page number 274. Now, if you look carefully in the table, you will see that the table is entered with LHA Aries. Every column represents a range of 10 degrees. 0 to 9 degrees is the range in the first column, then 10 to 19, 20 to 29, 30 to 39, 40 to 49, and so on. There are total 36 columns representing 360 degrees of LHA Aries. So for entering in the table, we have to first find out the LHA of Aries. The time of observation is given to us in the question. Using that time, we obtain the GHA of Aries from the almanac. The longitude is given to us in the question. Using the longitude, we obtain the LHA. Now, once the LHA is obtained, we can enter into the respective column as per LHA and get the corrections. The top part of the table gives us the A0 correction. Then the second part gives us the A1 correction. The third part of the table gives us the A2 correction. And the bottommost part gives us the azimuth of the pole star. Now let's see how do we obtain the values of A0, A1 and A2 corrections. Let's assume for the sake of an example that the LHA of Aries in a question is obtained as 65 degrees. So with LHA Aries 65, first of all we have to select the column. You can see the first column is from 0 to 9 degree 59. Then the next one 10 to 1959 and so on. So 65 degree is going to fall in this particular column, 60 degrees to 69 degree 59 minutes. So we enter in this particular column of the table, and when we go down, the first value which you see here, 0 degrees 16.8 minutes, this is for exactly 60 degrees of LHA. For 61 degrees, it is 17.2, 62 degrees, 17.5, and so on. When you go up to 65 degrees, you see the A0 correction. This top part is for A0 correction. The A0 correction comes out to be 18.6 minutes. So for 65 degrees LHA Aries, the A0 correction is 0 degrees 18.6 minutes. Now another thing which you need to pay attention to is that in case if the LHA Aries was 65 degree 30 minutes, 65 degree 30 minutes, you see now the value for 65 is 18.6 minutes and the value for 66 degrees is 19.0 minutes. For any intermediate value, we will need to interpolate between these two figures. So for 65 degree 30 minutes, the value will be exactly midway between 18.6 and 19.0, and that would be 18.8 minutes. So this is how we refer to the table and obtain the A0 correction. Interpolation may be required if you have a LHA value between any 2 degrees. Now moving on to the A1 correction. For obtaining the A1 correction, we continue in the same column which we entered using LHA Aries. So we had taken an example of 65 degrees LHA Aries. For A1 correction, you continue in the same column. And when you come to the second part of the table, you see the A1 correction listed here. This A1 correction is given against the latitude of the observer. So the DR latitude of the observer is given to us in these questions. In case in some question the DR latitude is not given, then in that case the altitude of Polaris can also be considered or taken as the DR latitude. So we enter with the latitude, and against the latitude closest to our DR lat, we pick up the A1 correction value here. The latitudes are given as 0, 10, 20, 30, 40, 45, 50 and so on. You can pick up the nearest value, which is the nearest value to your DR latitude. And if you have a look at the A1 correction also, there is no interpolation which is required in this part of the table. You can straight away pick up the A1 correction against your nearest latitude and it can be used. Now moving to the third part of the table. If you follow the same column which you had entered using LHA Aries, after A1, the next correction which is given here in the table is the A2 correction. In the third part of the table, you will see the A2 correction. A2 correction is given against the month of the year. You can see the month on the vertical axis on the left side. So depending upon in which month the site was taken, the observation was taken, you can go into that row and pick up the A2 value from the third part of the table. Now moving further, if you go down to the bottom part of the table, the bottom part of the table gives you the azimuth of Polaris. So azimuth of Polaris can be straight away read off from the table. We do not need to calculate it like other celestial bodies. It can be straight away picked up. The azimuth of Polaris is also given against the latitude. So the latitude which is given to us, DR latitude which is given to us in the question, we pick up the nearest value of the latitude to our DR lat, and then in that row the azimuth of the Polaris or pole star can be picked up. Now one important thing which you see here in the azimuth, that in this particular column, that is 30 to 39 degrees 59 minutes, in this particular column, if you have a look at the azimuth of Polaris, the azimuth is exactly 0.0. So if the LHA of Aries lies between 30 and 39 degree 59 minutes, then the azimuth of pole star, azimuth of Polaris is going to be exactly 000.0 degrees. That means the pole star is going to be exactly north of the observer. Now, if the pole star is north of the observer, then in that case, the position line which is perpendicular to the azimuth of the body will lie in the east-west direction. It is exactly on our meridian at that time, the pole star, bearing 000.0, and therefore the position line will lie perpendicular to it, and the direction of the position line will be exactly east-west. And in this particular case, whatever observed latitude or position line we obtain from the Polaris method, that is going to be our fixed latitude also. Now, in all other cases, you see the azimuth value is not 0.0. It is having some magnitude, either 0.1, 0.2, or 359.9, 359.8, and so on. So whenever the azimuth has some value, 0.1, 359.9, anything above or below 0.0, that means it is not on our meridian and the PL will not be east-west. But between this LHA range 30 to 39 degree 59 minutes, azimuth exactly 000.0, PL exactly east-west, and this method, the PL obtained also gives us the fixed latitude. If you go further in the table, you will see the azimuth becomes 0.0 again in a LHA Aries range of 210 to 219 degree 59 minutes. So in that particular range also, the azimuth being 0.0, the PL is east-west, and the Polaris method, the PL which we obtained using the Polaris method, gives us our fixed latitude also. Now, once you have obtained these three corrections, the A0 correction from the top part, A1 correction from the middle part, A2 correction from the third part of the table, you can use them in this formula which is given here. The formula says latitude, this is basically the observed latitude, is equal to apparent altitude corrected for refraction. Apparent altitude corrected for refraction becomes the true altitude of Polaris. Polaris or pole star is a star, and the only correction which we apply to the apparent altitude is the refraction correction. It does not have any semi-diameter, it does not have any parallax. So once you correct the apparent altitude for refraction, it becomes the true altitude. So true altitude of Polaris minus 1 degree plus A0 plus A1 plus A2 gives you the observed latitude. This observed latitude helps us to plot the position line. I will tell you the complete calculation in detail now in the coming slide. But this observed latitude, what we obtain, gives us the point or the position from where the PL passes. So beta, shall we move on to the method now?
Yes, sir.
Very good. Now, having understood the table, we can now obtain the values of A0, A1, A2 from the table. Let us now see how do we solve a Polaris site. First of all, let's see the information which is given to us in these questions. The information provided is the date and time of observation in GMT or the chronometer time. If chronometer time is provided, AM PM indication is given to us, and we use that to resolve the chronometer ambiguity. Second information which is given is the sextant altitude of Polaris, the index error of the sextant, and the height of eye required for dip correction. Along with this, the DR position of the ship is also given. Now the first step which we follow is we find out the GHA value, GHA Aries value from the almanac. We get the hourly GHA from the daily page. We apply or add the minute and second increment from the increment table and get the GHA of Aries, accurate GHA. To this we apply the DR longitude. DR longitude is given to us in the question, and we get the value of LHA Aries. Now, next step, we apply the corrections to the sextant altitude of Polaris. Index error is applied. If it is off, we put it on, means plus, and if it is on, we put it off, means minus. The height of eye gives us the dip correction, and dip correction is always negative. Once we apply the index error and the dip correction, we get the apparent altitude of Polaris. To this apparent altitude, we apply the total correction, and that gives us the true altitude of Polaris. Once true altitude is obtained, we get the correction A0, correction A1, and correction A2 from the Polaris tables. And all these corrections are positive corrections. So to the true altitude, all these three corrections are added, and we subtract 1 degree from the total to get the observed latitude. You can see the formula also coming up. Observed latitude is equal to true altitude plus A0 plus A1 plus A2 minus 1 degree. Now to plot the PL along with the observed latitude, we also need the azimuth of Polaris. The azimuth is found using the bottom part of the table, bottom part of the Polaris table. Azimuth is picked up from there. And once we have the azimuth and the observed latitude, we can now plot the pole star position line. The position line is perpendicular to the azimuth as always in celestial navigation. So once the azimuth is known to us, the PL is plotted perpendicular to it.
Sir, this azimuth will be with respect to observed lat or DR lat?
It will be with respect to observed lat. We will be plotting the observed lat only. We will not plot the DR lat.
But the value will be also with respect to observed lat, sir, correct, no?
Beta, the difference between DR lat and observed lat is so less that it does not make any change in the azimuth of the body.
Okay, sir.
सर ये ऑब्जर्व लैटिट्यूड एग्जैक्ट लैटिट्यूड है ना सर ऑब्जर्वर का?
नहीं बेटा, ये फिक्स लैटिट्यूड नहीं है. This also just gives us a position from where the PL passes. I'll show you the diagram.
बट ये जो सर सारे एरर लगा के हमने अभी इसका एरर पोलारिस के एरर्स लगा के जो हमने फाइंड आउट किया सर, वो लैटिट्यूड होना नहीं चाहिए सर एग्जैक्ट?
नहीं बेटा नहीं, बिकॉज PL इज नॉट ईस्ट वेस्ट बेटा. ये लैटिट्यूड ने सिर्फ हमें एक रेफरेंस पोजीशन दी है. द एक्चुअल लैटिट्यूड में डिफर.
बट सर ये जो NP इज इक्वल टू ZQ था सर, तो हमने NP फाइंड आउट किया ना सर अभी.
बेटा आपने उसे फाइंड आउट किया है बेसिस योर DR पोजीशन, करेक्ट?
यस सर.
आपकी एक्चुअल पोजीशन DR से जितनी दूर होगी उतना आपके लैटिट्यूड में फर्क आ जाएगा बेटा.
जी सर. ओके सर. ओके.
हाँ, I'll show you the diagram just now.
Okay.
Sir, one doubt, sir.
बोलो बेटा.
Sir, what latitude below equator can we see Polaris?
Okay. Basically, beta, for all practical purposes, it can be seen only in the northern hemisphere. Right?
Yes, sir.
But if you go very deep into it, see its declination is 89 degrees and 10 minutes. So maximum possible in southern hemisphere will be 0 degree 50 minutes south, no more than that.
Not more than that. Okay.
Okay. But that is theoretical for theoretical understanding. Practically, when the Polaris, when you are at equator, Polaris is going to be close to the horizon, and it will be very difficult for you to take a observation.
Correct, sir.
Okay, let me show you the diagram now, how we plot the Polaris PL.
Sir, where will we get this total correction of Polaris?
Beta, Polaris is a star, so the total correction will be from the stars table.
Okay.
Okay, great. Let's go and see the diagram now. Let's now make the plot of the Polaris observation. Now, for plotting the PL, we draw the dr longitude. The longitude used is the dr longitude. The latitude used is the observed latitude which we obtained from the Polaris site, working out the Polaris site. So observed latitude obtained from the Polaris site and the dr longitude gives us a reference position from where the PL will be passing. Now on this point we mark off the azimuth of Polaris or the pole star. Let's assume the pole star is here. So the red arrow shows the azimuth of the pole star and the direction of the PL will be perpendicular to the azimuth of the body. So you see the green color line having arrows at both the ends represents the position line in case of a Polaris observation. Now you can clearly see if the azimuth of the pole star is exactly 0.0, azimuth is exactly north, in that case the PL will be running in the east-west direction and the PL will then also be our fixed latitude. So this is the plot of the Polaris position line. So I hope that is clear now, beta.
Yes, sir.
Very good, beta. Great. So with this, we finish our site solving methods. All the 5 methods: Marpas, long by Cron, Intercept, X Meridian, and Polaris. People were missing those signs, leading to errors in their working. So what they did was they observed these values and they saw that the maximum error in A0 was about 0.3, minus 0.3. Same way in A1, the maximum value was about minus 0.3 and A2 also minus 0.3. So they totaled up all these negative values. It came to 1 degree. So what they did was they added this 0.3 in all the values. So everything became positive. All the corrections became positive and the table became simplified. You need not bother about the sign of the correction. And this 1 degree which was added to make the table simple was subtracted in the end by including it in the formula. Got it, beta?
Okay, sir.
The same thing is done in the moon's total correction table also. You see there is a minus 30-minute upper limb correction. The reason for that is exactly same. Upper limb corrections were negative. So to remove that negative sign, what they did was they added this 30 minutes to all the upper limb corrections and later on subtracted it using the minus 30-minute correction.
Right, sir.
Okay, great. So बेटा अब हमारा एक छोटा सा टॉपिक और है. That is the concept of a back angle. ये भी rarely आता है पेपर्स में, but sometime or the other the question can drop. So ये एक concept जो है ये हम अभी cover करेंगे. And इसके बाद हमारा site solving का जो part है that is complete. So you can practice these questions now from the PracNap book. All the site solving method, all the bodies you can do. And next class जो मेरी होगी उसमें I will be picking up the plotting exercises. So most probably next session में हम plotting complete कर लेंगे. And as soon as we complete plotting, I will be sending you assignment number 2. So that's the plan going ahead. Right?
So is that staggered and simultaneous? What are you saying? Plotting?
Both, beta. Both will come.
That is plotting. Okay.
That's right. Staggered and simultaneous.
Sir, you will give us some assignment or we will do it from tactical navigation supervisor?
नहीं, I'll give you assignment, beta. आज के लिए आप प्रैकनैव से प्रैक्टिस करो। जब मैं प्लॉटिंग कंप्लीट कर लूंगा फिर मैं एक असाइनमेंट दूंगा जिसमें थोड़े हायर लेवल के क्वेश्चन होंगे।
ओके सर, ये प्रैक्टिकल नेविगेशन जो ओल्ड वन वाला है सर, वी कैन यूज इट नो, या 2015-16 रीप्रिंट वाला चाहिए रहेगा?
नो नो बेटा, आप यूज करो 92 एल्मनैक आता है पेपर में अभी तक, सो द ओल्ड वन इज बेस्ड ऑन 92 एल्मनैक, दैट्स परफेक्ट।
बुक सर, बुक प्रैक्टिकल नेविगेशन बुक फ्रॉम कैप्टन सुब्रमण्यम, तो ओल्ड वन वी कैन यूज नो सर?
मैं उसी की बात कर रहा हूँ बेटा, ओल्ड वन यू कैन यूज, दैट इज परफेक्टली इन ऑर्डर।
नए वाले में सर
नई वाली जो है वो 2008 पे बेस्ड है, एग्जाम में अभी 2008 उन्होंने शुरू नहीं किया है।
सर हमारे बच्चे लोग जब जाएंगे तब आएंगे क्वेश्चन दे सकते।
ओके
भाई बच्चे को भी यही भेजना है
सर। वो बता दीजिए, अगर क्वेश्चन में मेंशन ना हो लॉन्ग बाय क्रोन या इंटरसेप्ट क्या है, तो सर क्या करना है फिर, कौन सा मेथड यूज करना है?
उसके लिए बेटा मैं ना आज आपको एक पीडीएफ डॉक्यूमेंट भेजूंगा, सो जस्ट गो थ्रू दैट पीडीएफ डॉक्यूमेंट, ओके, एंड इफ देयर आर एनी डाउट्स देन वी विल डिस्कस इट इन द नेक्स्ट क्लास, ओके?
ओके सर।
Okay, so now I am going
sir, one
into,
compliment
say again,
one compliment sir, आपके क्लास में ना सर द वे यू टीच वो इतना सही लगता है ना सर, इट ऑलवेज रिकॉर्ड वो गूगल वाला आता है सर, इतना पूरा आता है फिर।
okay great बेटा।
विष्णु सर अच्छा नहीं पढ़ाते क्या?
नहीं यार, but what I feel I told, I am not talking about Vishnu sir यार।
देखो बेटा, मैं एक ही प्रिंसिपल फॉलो करता हूँ कि हम जितने भी मेंबर हैं इस ग्रुप में, आई हैव टू गो विद द स्पीड ऑफ द वीकेस्ट मेंबर, ओके? सो आई हैव टू बी पेशेंट एंड आई हैव टू आंसर क्वेरीज वन बाय वन, वॉट एवर कम टू योर माइंड। सो इफ यू फील दिस इज वर्किंग वेल, दैट्स ग्रेट बेटा।
This is really working sir, thanks for that।
Okay बेटा, all right.
Just sorry to detour on that. Just one small doubt. So last time you had shared one
or used, but in the olden days when we were dependent upon celestial navigation for our position fixing, back angle was used whenever the situation demanded. So let's try to understand what this back angle technique is and how does it help us to obtain the altitude of a body. Now this back angle concept is used in those scenarios when the horizon is obscured due to any reason. The reason could be rain, it could be fog, it could be clouds, or there could be a coastline visible to you. Now because of all these reasons, it is possible that the horizon may not be visible. Now if the horizon is not visible to us, then we will not be able to take a celestial observation. We will not be able to take the true altitude of the body. For true altitude, we need to have the center of the body as well as the horizon both visible to us, and we measure the angle between these two using the sextant. So in these scenarios when horizon is not visible, it will not be possible for us to take a normal sextant altitude of the body. Now since in the olden days it was very important to take the sight, that was the only method available to us in open sea conditions where there were no land-based terrestrial navigates. This was the only means of position fixing. And if we are not able to take a sight, the vessel will be in doubt where the actual position is. So we tried our best to obtain the position line in whatever situation we were in. Now in these scenarios also, it seems we will not be able to take the sight, but there is one possibility which is available. And that possibility is if the horizon on the opposite side is visible to us. Let me give you a practical example. Let us say you are coasting and you are coasting on, let us say, Indian West Coast, You are passing Mumbai and moving in the northwest direction. Now you have the coastline on your starboard side. Now let us say the sun rose and at about 9 o'clock, 10 o'clock you went on the bridge and you wanted to take a sight. But you will have the coastline and the horizon will not be visible to you. Now this is where the back angle technique can help you. Instead of using the horizon in the direction of where the body is, we can use the horizon opposite to it and obtain the altitude of the body. Now how is it done? Let us try to understand using a diagram. You see this diagram now. We have the earth in the diagram. We have the earth. Then we have the center of the earth at this particular place. We have the observer at point O. Observer has got some height of I also. You can see he is above the surface of the earth. C represents the center of the earth. And the celestial body which we are trying to observe is this particular star named as X. Z represents the zenith of the observer. Now this line which you see passing from C, R dash, passing from the center of earth, represents the rational horizon of the observer. Rational horizon plane passes through the center of the earth. You can see it passes from the earth center and every point on it is 90 degrees away from the zenith of the observer. So this is our rational horizon. Now from the observer's eye, if we draw a tangent to the surface of earth, from the observer's eye, we draw a tangent to the surface of earth. You see this is the tangent in one direction. This is represented by OV dash. This represents the visible horizon of the observer. If you see on the opposite side, then from the observer's eye you draw a tangent. You see OV is the visible horizon of the observer. Now, if you draw a line or a plane passing from the eye of the observer and parallel to rational horizon, you see this is the observer's eye and we have the rational horizon as R dash. This is the plane of the rational horizon. So from the observer's eye, if you imagine a plane which is parallel to the plane of the rational horizon, which is represented by S dash in the diagram, this is the sensible horizon of the observer. This is the definition of sensible horizon of the observer. So we have the sensible horizon also here represented by S dash. Now the situation is such that in the direction where the body is, you see this body X is in this particular direction. In a normal scenario, we would have used the visible horizon OV dash to obtain its altitude. But the situation is such that this particular horizon is not visible to us. There may be coastline, rain, fog, clouds as discussed earlier. So this side of the horizon is not visible to us. So that's why I have put a cross over here. But the horizon on the other side, which is OV, diametrically opposite to the direction in which the body is, exactly reciprocal opposite, this side horizon is visible to us. So if you have coastline on one side and the other side is clear, you will be able to see the horizon on the other side. So horizon on the other side is visible to us. This is the scenario, or this is the situation where the back angle method can help us. So even though the horizon in the direction of the body is not visible to us right now, we can still obtain the altitude of the body using the back angle technique. Now let's try to understand what this technique is. Now, in a normal scenario, if this coastline or rain or fog or cloud was not there and the horizon was visible to us, OV dash horizon in the direction of the celestial body was visible to us, we would have obtained this particular green color angle using our sextant. This is the angle which we would have obtained. This is the angle between the center of the body, represented by OX, and between the visible horizon of the observer, represented by OV dash. So this angle XOV dash is what we would have obtained from our sextant. Now once you obtain this angle, the correction what you apply to this angle after the instrument error, after the index error, the next correction which we apply is the dip correction. The dip correction. Now what is the dip correction? Dip correction is basically the angle between the sensible horizon and the visible horizon. Let me show you here in the diagram. You see this particular maroon color angle. This is the angle between the sensible horizon, represented by SS dash, and the visible horizon, represented by OV dash. This is known as the dip angle. The full name of the dip is dip of the sea horizon. Basically, it tells us how much is the visible horizon dipping below the sensible horizon. That's why we call it dip. So we would have applied the dip angle or the dip correction to this angle which we have earlier obtained. We have seen the dip correction now applied here. Now once you apply this dip correction, the maroon color angle is subtracted. You would have obtained angle XOS dash. This was the apparent altitude of the body. So to the apparent altitude, we would have applied the total correction and we would have obtained the true altitude. This would be the normal method when the horizon is visible to us. But now we do not have the horizon available to us because of any of these reasons. So we cannot follow this particular method. So what do we do now? Now, since the horizon on the opposite side is visible to us, that is OV, this side of the horizon is visible to us, instead of measuring the angle to the normal horizon, we measure the angle from the center of the celestial body to the horizon in the opposite direction, represented by the blue color angle in the diagram. The blue color angle which you see is the angle between the center of the body and the horizon on the opposite side to which the body is. So we have used the sextant to obtain the angle between the center of the body and the horizon in the opposite direction. Now obviously this angle will be more than 90 degrees. A normal sextant altitude would always be less than 90 degrees, but this being a back angle observation will be greater than 90 degrees. Its value will be more than 90 degrees. So if you get a question in your exam where the angle is given as more than 90 degrees, don't think that it is a misprint. It could be a back angle observation. So we have obtained this back angle now. The back angle is obtained. Now how do we proceed ahead from here? Now the blue angle which we have obtained is angle XOV. X is the center of the body, O is the observer's eye, and V represents the horizon in the opposite direction. Now to this angle, after applying the index error, obviously that is the instrument error, we again apply the dip correction as usual. We would be given the height of eye of the observer in these questions. So we get the dip correction and we apply the dip correction to this blue angle. So let us see what happens once we apply the dip correction. You can see the dip correction now represented by the maroon color angle. This is the dip correction applied to the horizon on the opposite direction, reciprocal direction. So once you apply the dip correction, the angle which we have now obtained is this blue color angle. The angle which is available to us now is XOS. And if you look carefully, this particular angle is basically 180 minus apparent altitude. You can see the sensible horizon SS dash. It is a straight line. It is a plane, or in this diagram it is a straight line passing from the eye of the observer and parallel to the rational horizon. So the angle which we have obtained now, that is the blue color angle, and the angle which we require, which is the green color angle, they will add up to 180 degrees. So if we have obtained the blue color angle, 180 minus this angle would give us the apparent altitude what we require. So 180 minus the blue color angle which we have obtained, we call this also as apparent altitude in the back angle calculation. Once you do 180 minus apparent altitude, you get the corrected apparent altitude. The green color angle is now called a corrected apparent altitude. So once you obtain the apparent altitude, further calculation is easy. It is exactly same as we did before. We apply the total correction and we get the true altitude of the body. So this is how we obtain the true altitude of the body using this back angle concept.
So that corrected also will be more than 90 only, right?
No, beta. Once you subtract it from 180, that is 180 minus apparent altitude, it will be less than 90, beta.
But looking at that blue angle, it looks like it is more than 90, right?
Beta, the blue angle is to be subtracted from 180 to get the green angle, that is the corrected apparent altitude. Corrected apparent altitude is the green color angle.
Yes. Got. So we are interested in the green part basically. Yes. Sorry.
That is right, beta. That's right.
So just 1 minute. Can you hold the slide here?
That's right, beta. The sextant can measure angles up to a maximum limit of 120. Okay, beta. Great. So I hope that's clear.
सर एक बार जस्ट एक लाइन में सर सीक्वेंस में बता दीजिए हमने सर क्या क्या किया है इसमें सर. सबसे पहले हमने सर एपरेंट सॉरी इसका साइड लिया सर बैक एंगल से डिप लगाया, ऐसे बता दीजिए सर एक बार.
बेटा ये लेफ्ट साइड में देख रहे हो, एग्जैक्टली यही किया है बेटा. बैक एंगल लिया, डिप लगाया, जो एपरेंट ऑल्टीट्यूड आया उसे 180 से सब्ट्रैक्ट किया. इट गिव्स अस द करेक्टेड एपरेंट ऑल्टीट्यूड. हमने टोटल करेक्शन लगा दी, ट्रू ऑल्टीट्यूड आ गया.
तो वो जो राइट साइड में सर डिप लगा है वो
दैट वाज जस्ट टू एक्सप्लेन टू यू बेटा.
अच्छा, उसकी कोई जरूरत नहीं है ना सर, बस यही वाला पार्ट.
राइट.
ओके.
Okay, beta. So if you are comfortable, shall I close the presentation?
ओके सर. बाय सर.
पीडीएफ को ही मतलब रिवाइज किया जाए.
बेटा अगर आपको टाइम ना मिले पास पेपर करने का, तो मैंने वो जो असाइनमेंट है उसे ऐसा बनाया है कि वो भी लाइव पोर्ट का काम कर देगी. बट आई वुड रिकमेंड कि आप उसको करने के बाद भी व्हेन यू गेट टाइम यू कैन जंप इनटू पास पेपर एंड ट्राई इट आउट. ओके, but most probably I would say 90% of the concept will be covered. Anybody has seen through past papers? What's your feedback?
Same question as our digit we match करते हैं.
Maximum is maximum matchable, sir. So that's why I asking
Exactly,
time to कहीं waste तो नहीं कर रहे हैं.
Exactly. If you do the assignment, that basically prepares you for the paper, beta.
Okay, sir. Thank you.
So can I ask you one
But I can never guarantee that the question is going to come from the assignment. So that cannot be guaranteed.
हाँ सर, कंसेप्ट बेसिकली ऑलमोस्ट उनमें से आएंगे. वही क्वेश्चन रिवाइज करते रहेंगे सर.
Right, beta.
So I have one question regarding this back angle. एक छोटा doubt है. I don't know. Sir, I mean, if I'm trying to imagine this question, like if you are solving on the ship. Sir, you first started with a comment saying that the sensible horizon is not visible, OV dash. So how can we get the apparent sextant altitude only if your horizon is not visible?
Beta, sextant altitude is obtained from the visible horizon.
Correct, and वही visible नहीं है sir.
Opposite side में visible है ना बेटा?
एक तरफ लैंड है,
थोड़ा इमेजिन करने थोड़ा गलत लग रहा है.
ओके मैं आपको बता देता हूँ बेटा कि इसको प्रैक्टिकली कैसे लेते हैं. सो रिटर्न में तो कोई नहीं पूछेगा, ओरल में somebody may ask you. Okay, so just keep looking at me. Let us assume that you have the body on this side. Okay, you have the body on this side.
Okay.
अब आपको अगर बैक एंगल लेना है, you have to face the opposite side. Like this. So body comes at your back.
Yes sir.
Okay. अब बेटा किसी और बंदे को ना स्टैंड बाय रखो अपने पीछे ताकि आप गिर ना जाओ. You need to warm up a little bit. अब आपको सेक्सटेंट पकड़ना है. You have to aim in the opposite direction and then bend backwards. Catch the body and then bring it to this particular horizon. समझे बेटा?
परफेक्ट, अब समझा. अब सारे डाउट निकल गए. वेरी
अब हो जाएगा. अब जहाज पे सर सब साइड सारे साइड हो जाएंगे हम लोग.
ओके, ऑल राइट.
यही करना ही है सर, और करना ही नहीं है ये साइड ही.
What you said right now, nobody had the answer to this question. I of taking the back angle. No, everyone is like नहीं कुछ ना कुछ दिख जाता है. But today what you said was like very much practical. Yeah, thank you sir.
किसको पूछा भाई लास्ट टाइम? किसको पूछा था? कैप्टन को?
कैप्टन विशन सर.
हाँ.
नहीं जहाज पे कैप्टन को पूछा क्या?
Yeah. He also did not know.
अरे उसको लैड बाय मरपस पूछता ना, वो भी नहीं बताओ.
ओके बेटा, ऑल राइट.
कैप्टन से पूछा होगा.
Let's break off for today and I'll see you in the next class.
Okay sir, bye. Thank you.
Okay sir, thank you.
Bye bye. Jai Hind.
Okay sir, Jai Hind. Bye sir.